Hey guys, welcome to the channel, and today we'll be discussing everything about unit testing in JavaScript. We'll first start by defining what a unit test is, and then we'll go ahead and install the Jest framework, which is the framework that we'll be using to write the unit test for our JavaScript application. And then we'll dive deep into the intricacies which go behind the concept of a unit test. Also, this video will be the first video in a series of videos that I'll be making about unit testing in JavaScript. In this series, we'll first start by writing basic unit tests, then we'll move into writing unit tests for your asynchronous code, your backend APIs, and then we'll also move into writing unit tests for your UI components if you're using libraries like React or Next.js. So without any further ado, let's start with the basics of unit testing. So here we are on VS Code. And let's go over the definition of a unit test first. So a unit test is a method which isolates a single unit of the application and verifies its particular functionality. The unit which is being tested is often also referred to as system under test or SUT. So for example, in our current directory, we only have one JavaScript file by the name of utils.js. This particular file has two functions, and we're exporting both of these functions with the help of module.exports. Now you definitely must have seen the example of this sum function before while looking at other tutorials about unit testing on YouTube. But don't worry about it, this tutorial will not be as basic, and we'll dive deeper into the different kind of unit tests that we can write around a function, and we'll also improve the function as we go. So by our definition here, a unit test is only supposed to isolate a single unit of the application and verify its functionality. So out of the two functions present here, let's say we want to write the unit test for the method sum. So here this particular sum method becomes a system under test or the unit which we want to test out. Now this function is pretty simple. It just takes in two parameters a and b, adds their value and returns it. So the test for it will also be pretty simple. So to test it out, all we need to do is invoke the sum function with two numbers, let's say 2 and 3, and we expect the return value to be 5. And if this is happening, we can say that our function works as intended. So the job of a unit test is basically to write this behavior in code and to check if we are getting the expected result back. We'll do all of this with the help of the Jest framework, which is a standard testing framework used by most of the JavaScript projects. So now, since we have defined what a unit test is, unit testing as a whole is nothing but writing a collection of automated unit tests for all the different units of your application. So as of now, we have two methods in this particular file. If we write unit tests for both of them, we will be covering all of the methods that are currently present in our code. And that's the basic idea behind unit testing, that we cover all of the code that we have in our application and verify whether they are functioning as they should. And that's the exact reason why we need unit tests. Unit tests ensure that your code behaves the way it is supposed to, hereby improving the overall quality of the code, and it also helps in exposing any defects that might be present in your code base. So let's start with our very first basic unit test. We'll start by installing the Jest library in the node modules folder of this particular directory. But as you can see, we haven't initialized a Node.js project yet. So we'll open the terminal and we'll type in npm init and we'll pass the y flag so that it auto generates a package.json file for us. Now as you can see here, we do not have any dependencies installed yet. So our next step is to go ahead and install the Jest library into our application. And one thing that you should always take care of is that we always install Jest as a dev dependency. And that's because a production code doesn't really need a testing library to run the code. So all the testing libraries are not supposed to be included in the production bundle of your application. So it's always a good practice to add the save dev flag after the install command. So I'll hit on enter. And after a while, you'll notice that Jest has been installed as a dev dependency inside our new Node.js project. So let's go ahead and write our very first unit test. We'll create a test file which we will name as utils.test.js. So the general standard that's followed is that you write the name of the file followed by .test and then the JavaScript extension while naming your test files. Now As I said before, a unit test is just a method which we can run to test a particular unit of the application, and the unit that we currently want to test is the sum function. So as the first step, I'll import sum method from the utils.js file by using the require statement. And the way you define a test with the Jest library is by using the test method that's available to us. So we'll just simply invoke test. It takes in two parameters. The first one is the description of the test itself, and the second one is a method which runs and actually tests the function itself. So we'll give the description as sum method is able to add two numbers successfully. So this is a description of the test that we're going to write. Now within the actual test function itself, we are going to break our unit test into three different stages. And these stages are in general named as arrange, act, and assert. Now the arrange stage or the arrange phase is where you write the steps to create the instance of the system under test and set up all of the necessary fixtures, which are maybe, let's say, test environment data or inputs that are needed by the function. Since our function is pretty simple, the only setup it needs are the two numbers which are going to be passed as parameters. So our arrange step is pretty simple. We just need to define two numbers. We'll call them a and b respectively. The value of a is 10 and the value of b is, let's say, 5. Next up, the second stage of a unit test is basically to invoke the system under test and act on the inputs that we gave in the arrange step. So in the second phase of the act phase, we invoke the system under test. For example, since we are dealing with function, we can simply call the function with the necessary parameters and wait for the function to return a response. Even if the function does not return a response, we just need to look at any side effects that the function might be causing. But since our sum method here is actually returning the sum of the two numbers being passed, we can simply store that result in a variable. So we'll implement the act stage. Here we'll say that in the result variable, just store whatever the sum method returns while passing a and b as the parameters. So we're also done with defining the second stage of the unit test. Now the third and final stage is to actually check if the result is proper or not. And this stage is called the assert stage. So here we are checking if our system under test passed or failed with the provided inputs. So in any testing library, to check the final result, you have certain predefined methods or APIs which are called matchers, and using these you can check if your result was proper or not. So let's go ahead and implement the assert stage. It's called the assert stage because we're basically asserting that our system under test is returning the proper result. Now, as I said, we'll be using something called matchers. You can go to the official documentation of the Jest library to see what all matchers are available to you. I'll just open the documentation, and what we'll be using is the expect matcher. So here I am on the official documentation of Jest, and I'm looking at the using matchers page. I'll add a link to this documentation in the description below, and we'll be using the most common matcher, which is 2b, which is used to check the equality. So here a very simple example is also given. We are basically checking if 2 plus 2 actually equals 4. And the way in which you can access this matcher is by using the expect API. So we'll write something very similar. We'll copy this particular line into a unit test, and here instead of 2 plus 2, we'll just say that we expect the result of the sum method to be equal to 15 because we know 10 plus 5 is 15. And we're also expecting the value returned by the sum method to be of the same value. And that's basically it. We're done with our very first and very simple unit test. It has all of the three stages which are required in every unit test. So the first stage is the arrange stage, where we arrange all of the parameters that we need to pass to the sum method. Then in the second stage, we are actually invoking the sum method and storing the return value in the result variable. And in our final assert stage, we are expecting the result to be equal to the value 15. Now to actually run this unit test, in the terminal, I'll be typing in npx jest and I'll be hitting on enter. And you'll see in the console that the one single test that we defined under the file utils.test.js actually passed successfully. Now here you're seeing something called as test suite. A test suite is nothing but a collection of unit tests. For now, you can just assume since there is a single unit test being executed, there's only one test suite. Now this was a very simple unit test for a very simple function, which is just returning the sum of two numbers. But in reality, functions are much more complex and are often invoking other functions inside them. For example, in our utils.js file, we have another function called salary. Now this particular salary method takes in the basic amount, the bonus and the tax percentage as the three parameters. It first calculates the payable amount after deducting the tax, and then it calculates the total salary by adding the payable amount with the bonus. But since we can also call the sum method for this operation, what we'll do is we'll pass the payable amount and bonus as parameters to the sum method and just store the returned value in the total variable. Now, as you can see here, this salary method now has a dependency on the sum method. But when we'll be writing the unit test for the salary method, we will only be isolating this particular method, and it's not our concern what this sum method is returning. So what we generally do is we mock the behavior of the sum method and we'll assume that it returns a certain value. And we do this because we want to stay true to the definition of a unit test, which is that we only test a single unit in isolation. So since the system under test here is a salary method, we should not care about what sum method returns. So to write the unit test of the salary method, what we do is we mock the behavior of sum method instead of actually invoking the sum method. And here the whole concept of mocking comes into the picture. We'll cover mocking in a different video in the future, but I just wanted to show you an example of a more complex function which has dependency over other functions. So for now, I'll just collapse the definition of this particular salary method and we'll focus just on the sum method. Now, one more thing that I had mentioned in the markdown file here is that assertions can also be used to check if the system can handle errors gracefully, and such tests are also called negative unit tests. So what we have written so far is an example of a positive test case where we're checking how the system behaves under the right conditions. But what if instead of a number, we pass a string to the particular method? So let's add another unit test. This time I'll give the description as sum method should not be able to add a string to a number. And in the actual test definition here, everything will remain the same. So I'll copy all of the steps from our previous test and I'll paste them here. But in our arrange phase, instead of having the value of the variable a as a numerical value, what we'll do is we'll pass 10 as a string. Let's save the changes, and we're expecting the sum method to return the value 15 itself. But let's see what the actual result is. So we'll run the test suite again by typing in the command npx jest. What you can also do is edit the test command in your scripts section under package.json. So for now, the test script just prints this particular message. So we can simply replace this random message by npx jest command. And now every time you run npm run test, you will basically be running the jest command. And since this command is already present under package.json, you also do not need to mention npx. You can simply just write jest. So we'll type in npm run test, hit on enter, and you'll see that we're getting a few errors logged out on the console. And if you scroll a little bit up, you can clearly see the reason why. Out of the 2 total tests, only one passed and the other one failed. Let's scroll a little bit up further, and you'll notice that the sum method returned 105 as a string instead of returning the number 15. And that's because we pass a string into our sum method. Now, general idea here is if you try to add a number which is a string to an actual numerical value, what happens is that JavaScript typecasts the other number into a string and concatenates both the strings. So this 5 is basically treated as the string 5, and you see the concatenated value as 105, which is also a string. So cases like these are also called edge cases, where the inputs are not proper. So instead of passing numerical values, we forced the function to fail by passing in a string value. But our function should be smart enough to handle such errors. So that's why what we'll do is we'll edit our function a little bit. On top here, before returning the sum of a and b, we'll check if the type of a and b is actually number or not. So we'll add an if condition here where we'll check if type of a is not equal to number, or if type of b is also not equal to number. Then our method should throw an error with the message that only numbers are allowed as inputs. Now as per the input value, we have edited our function. Let's run the tests again. So we'll run the npm run test command. You'll see that we're still facing the error, but this time if you scroll up, you'll see that this particular error message was thrown. Now in our assert stage, we can also check if the system can handle errors gracefully. So what we basically have to do is, instead of expecting the result to be a number, we'll use a different matcher which can be used to verify the error thrown. So we'll go back to the documentation. Here we'll go to the exceptions section of the page where we'll find the toThrow matcher. Now they have also given an example here. They have written a function which throws an error with this particular message. Now while testing this function, they're using the expect API and they're invoking the method inside the expect call itself, and post that they're also invoking the toThrow matcher where they are verifying the error message. So we'll just copy this particular line and paste it inside our code in the assert stage. And you'll notice that since they are invoking the method inside expect itself, what they have done is they have merged both the act and assert stage. So we'll remove the line 20 and 21 completely. We'll call the sum method and we'll pass a and b as the parameters, and we're expecting this method to throw this particular error message. So we'll copy this error message and paste it inside the toThrow matcher. We'll save the test and rerun the npm run test command. But this time you'll notice that both of our tests were successful. So both of our positive test case and the negative test case are now passing. So with the second example, you also saw how you can catch bugs with the help of a unit test. So when we pass the string value to our sum method, we noticed that it was returning a concatenated string in the response, which was not expected. So we modified our sum method to throw an error if the type of the input parameters wasn't number. So that was basically it for this video. We went through the definition of a unit test. We saw how we can write a unit test using the Jest library, and how each test can be broken down into 3 phases: arrange, act, and assert. We also wrote a negative test case along with a positive test case, using which we were able to expose a defect in our system under test, and we modified that system to behave properly. In our next video in the series, we'll see how you can test asynchronous code. So I'll see you in the next video.